Okay, let's go ahead and get started. Okay, to start off the class today, being our last class, we're going to actually go ahead and go over the study companion that is put out by ETS. Hopefully you've had a chance to look at it. If you have not had a chance to look at it, if you'll notice right here, we're at the Praxis page at the UPDC. So for those of you that are here, it's at updc.org/Praxis. For those of you online, it's just at the bottom of the page that you went to in order to log on to the class today. And down at the very bottom, there's something called Other Resources, and it is the Praxis 5169 Study Companion. This is put out by ETS, and it tells you everything you need to know about your test, so we're going to kind of go through this a little bit and look at some of the things. The very first part, if we go in a couple pages, you've got your table of contents, and it's just going to kind of break it down. It starts out very general, taking a Praxis test in general, and then it goes into your test specifically that you're going to be taking. I would recommend you read through the whole thing, but we are going to go ahead and skip directly to your test exactly, which is on page 11. Now, we've actually shown you this before. At the very beginning, we gave you we actually gave you the practice test that was in here. That's where that very first test came from. So just kind of doing a quick test at a glance, and what it actually means is you have 2 hours in which to take this, which you're probably very familiar about the time for the test, but you'll also see that you have 55 selected response and numeric entry questions. Meaning, you want to kind of pace yourself a little bit. If you're finding that a question is taking you an extraordinary amount of time, you're going to want to skip it and go back to it. You've got about 2 minutes a question, is how you can kind of pace yourself. So if something's taking you 5, 6, go through and answer all the questions you can very quickly, and then that will give you time to go back and answer those ones that are taking a little bit more time. You want to kind of pay attention to when you're getting close to the end of your test, because when you get closer to the end, so pay attention to that time, because you are not penalized for choosing an answer. So at the end of the test, even if you're not finished, you're going to want to answer every question. So you don't want to run out of time where you're not able to do that. Make sure you answer every question. Okay. On here you can see where it was broken down that arithmetic and algebra is going to be 62% of your test, where the geometry and data is the 38%. And I know a lot of you would have liked to have seen more emphasis on geometry, but you can see why we chose the arithmetic and the algebra to really focus on, because that's where a lion's share of your test is coming from. Down at the very bottom of this page, what we want to point out to you is this. You get your raw score when you finish this test. Your raw score is going to pop up. It's okay. Take a deep breath, because this sentence right here says this test may contain some questions that will not count towards your score. So if you found a particular question that maybe you don't think you did very well on, it's okay. It may count, but it may not count. So don't get overly caught up in one question that you were a little frustrated with, because it may not count. Right there on the paper. Okay, let's go ahead and go to the next page. You should recognize these. We actually printed and hand these out to you. These are the topics that are covered. I would highly recommend, as you're preparing for your test again, that you go through and just make sure you're comfortable on those topics again. If there's an area you need a little bit more help on, then I would go back and look at some of those areas. Okay, then we get to the types of questions after we saw the areas that it covers.
Sorry,
it's okay, we're almost there. There's lots of areas that it covers. Oh, yep, a little more. And here we are. The types of questions here. What this kind of reminds me of as I read through these descriptions here is it sounds a little bit like our SAGE test is going to be for this coming year. So if you've kind of been in and played around a little bit with the SAGE practice test, the types of questions sound very similar here. And that is multiple choice questions where you can select one answer choice. Sorry, I'm fidgeting. Multiple choice questions where you can select one answer choice, which is what we're kind of used to seeing. But then we have multiple choice questions where you can select one or more answer choices. And it will usually say in the directions something like choose all that apply. You'll also notice that in that little description, it will tell you that you'll have square boxes. So instead of them being circles that you click on, there'll be little squares that you put a check mark in. And that kind of gives you another clue that you're choosing all that apply. Because there'll be little square boxes. Then we've got the numeric entry. So this would be if you're going to type in a decimal or an integer or a fraction, and you'll just type the numbers using your keyboard directly into the boxes. So these are going to be some of your more open-ended questions where you have to do some calculations. Then you're going to have some drop and drag questions. This is where you might be asked to pair up phrases or expressions with a graph or another equation. So you'll actually click with your mouse and drag it into the appropriate area. And then the very last type of question that you could experience is the table grid questions. And these look like they've got some statements in the columns and that you have to go through and put all of them that apply. So you basically fill in the table with the statements that apply. Then over on the other side, it actually talks about the calculator. And we've had a lot of discussion about the calculator. And so we just want to kind of really hit on this again. There is the link right there. If you have not downloaded that practice calculator, there's the link to that practice calculator again. We highly, highly, highly recommend that you download that practice calculator and play around with it. Especially beads where you only have 2 hours to take this test. The last thing that you want to do is be trying to figure out how to use the calculator. Now the calculator can be used to perform all different kinds of operations. It can also be used to graph and analyze functions, to find solutions to equations, and to generate a table of values. So there's a help manual that goes with it. Read through that, play around with it, experiment with it. That's the best way to learn about a calculator, is to go ahead and play around with it a little bit. Okay, under using your calculator, if you go back up a little bit, you'll notice in that second paragraph, under using your calculator, so we have 2 paragraphs, the very last sentence in that second paragraph, it says, do not use a calculator if you do not need to. You will waste precious time. So if there's a simple calculation you can do in your head, do, by all means. And you probably have seen maybe some of your students actually grab their calculators to do things like 0 plus 7 or 0 times something. That's where test anxiety kind of takes over a little bit. Leave it, put it aside. If you can do the calculation without a calculator, do. It will save you a little bit of time because you're not pushing those buttons. Okay, if you look down to the 4th paragraph, so 2 paragraphs from down, do not round any intermediate calculations. Okay, what that means is, if you're working out a problem and you get you're halfway through the problem and you get 8.33333, it fills the whole screen, and now you need to multiply it by another number. Let's say you need to multiply it by 6. You do not want to retype that in as 8.3 times 6. And the reason is because it's going to give you an answer that's slightly different from the actual answer. You'll be off just a little bit. So you want to keep the whole number in the calculator when you're doing calculations and just continue to do the calculations on it. We saw this a little bit when we used pi. If you remember when we used 3.14 versus the pi button in the calculator, we saw a difference in calculations. So that's one thing that you want to pay attention to, is not to round. The very last paragraph there, be sure you read the question carefully to know what you're actually being asked. A lot of times there'll be a calculation you have to perform. So you go to your calculator, you perform that calculation, and then you immediately look at the answers and you see the answer. Go back and double check to make sure that's actually what it's asking for. So just double check to make sure that what you're answering is really what you've been asked to answer. Okay, talking about, okay. Then it goes back into some more general in section 5. It talks about, a study strategy, how to study for success, which is kind of what we've done. So if we'll go to section 7, review SMART tips for success. So this is developing your study plan. Okay, should I guess? I just wanted to re-point this out to you. Yes. Your score is based on the number of questions you answer correctly. You do not get a penalty or a subtraction for getting an incorrect answer. When you don't know the answer to a question, try to eliminate any obvious wrong answers, then guess at the correct one. Try to pace yourself so that you have enough time to carefully consider every question. Okay? And then, can I answer the questions in any order? Yes. You can go through the questions from the beginning to end, as many test takers do, or you can create your own path. Perhaps you want to answer all the questions in your strongest area of knowledge first, and then move from your strengths to your weaker areas. On computer-delivered tests, you can use the skip function to skip a question and come back to it later. There's no right or wrong way. Use the approach that works best for you. So again, if you get hung up on a question, instead of spending a lot of, if you can tell it's going to take you a lot of time to answer that question, quickly move on to the ones that you can do. Because time is an issue. The last thing that you want to do is have unanswered questions on your test. Okay, then if you'll notice, we've got in section 8, the next section, this is where your practice test came from. So you can take a look at that again if you wanted to. It also has at the very end of the practice test, it has the answers and an explanation as to why the answer is what it is. And why the incorrect answers do not work. So that should look really familiar. And then if you foresee you need any testing accommodations, here we'll talk about the accommodations. But we're going to go ahead and move. The last part I want to talk about is section 10, which is do your best on test day. Just a quick reminder, these are just some strategies that anytime you take a test, you're kind of usually reminded about is make sure you're well rested and that you're wearing comfortable clothes. And it was always a good suggestion to dress in layers, especially if you're someone who typically gets very warm in a situation or gets very cold in a situation. That way you can be comfortable. You want to make sure that you eat adequately before you take the test. And make sure that you take your ID with you. There's nothing like being ready to take the test and you realize you don't have your driver's license. It's kind of like being at the airport realizing you don't have your driver's license with you. It just causes stress. Here it says bring a sharpened supply of number 2 pencils, but this is for if you're doing constructed response or paper delivered test, which you are not yours as a computer, but you're still going to want some pencils so that you can do it on scratch paper, so that you can work out some of that work. What items are you restricted from bringing? So if we go down a little bit. I just wanted to point these out because I think we had a lot of questions on this and I don't think we were ever very clear. And you cannot bring into the center personal items such as, please notice right there, it does say a graphing calculator. So you are not allowed to take in your own graphing calculator according to their handbook. So, question? Okay, so it looks like maybe depending on your testing center, you're going to want to call them because they may make different accommodations then. Those of you out in Adobe land, the comment was they had called the testing center and their particular testing center said that it was okay to bring their own calculator. But do not go on the assumption that you can take in your own calculator. Make sure that you either checked or you are ready to use that online calculator. Thank you for that, by the way. Also, please notice that you cannot take in your own scratch paper. They will supply that for you, okay? Or any notes or books or things like that. So that's just kind of an overview of the test that we kind of wanted to re-emphasize. Things like practice using that online graphing calculator. Make sure that you pace yourself. There are 55 questions. And if you get really frustrated about a particular question, it's very possible that it's not even going to count towards your score in the end. So take a question at a time, and do your best, but don't be overly stressed about it. Okay, so I think we'll go ahead and move into some examples from questions that were sent to us. By the way, thank you to those of you that who emailed us with questions that you would like to see or problems you'd like to see worked. We did receive quite a few of them, so that's what we're doing. We did it again. That's what we're going to spend some time today working on. And we're going to start with the probability ones, correct?
Yes.
Turning it off.
Okay, can you guys hear me?
Yeah.
Okay. So Chantel wanted me to do the probability questions because I enjoy them so much. Okay. So let's see. We'll just kind of go through. There was one that was asked that was a good hairy question, and it was fun. So I wanted to hit that one first. Remember which one that was. Okay. Yeah. Okay, here it is. So it is on the probability handout, number 7. And it says, there are 4 purple, 4 orange, and 4 black marbles in a hat. You pick 4 marbles from the hat. Marbles are not returned after they have been drawn. Now, that's an important part of that question, that the marbles are not returned after they've been drawn, because that actually complicates the question quite a bit for us. So, what we're looking at do you know where the black marker went? Go to blue. I don't know how well the blue is going to show up. Okay, so what we're looking at is we've got 4 purple. Oh, there it is. Okay, blue's showing up. Thank you. Okay, 4 purple, 4 orange, and 4 black. And we're going to find the probability that the first marble is not orange. The second marble is orange. The third marble is black. And the fourth marble is orange. So, here's why this gets a little complicated for us. Because if we pick a marble and that marble is not orange, what colors could it be? Purple or black. And here's why that messes things up for us. Because if it's purple, how many black marbles are going to be left when I get to that third marble? 4, right? Because we haven't pulled any black marbles out. But if I pull a black marble out that first time, how many black marbles are left? 3. So we've got 2 different groups of probabilities that we need to look at. We need to look at, okay, if the not orange is a purple one, or if the not orange is a black one. So we're going to have 4 marbles there, and 4 marbles there. So we're going to figure the probability of these plus the probability of these. So, again, I'm just going to, I'm going to abbreviate down underneath here. So the not orange, for this one, I'm going to say this is purple. Then the next one is orange, then black, then orange. For this one down here, our other choice for not orange is going to be black, orange, black, orange. Okay? So, the very first, the probability of the first event, the probability that it is not orange. So what is the probability that it is not orange? For, let's look at purple first. What's the probability that we pull a purple out? Okay, so 4 out of 12, right? Or 1/3. How about the probability that it's orange? Well, we've got 4. How many marbles do we have left in there after we pulled one out of this first? Okay, so we originally had 12, now we're down to 11. So we've got 4 out of 11. Okay, then we go to black, and this is my very first black that I'm pulling out. So I've got 4 black marbles, and how many total marbles are in there? 10. Okay, so then my last one, orange. How many orange marbles are left in there? 3, because we pulled one out here, right? And how many total marbles are in there? 9. Okay. So then let's go down. Okay, we're multiplying all those. I'm going to add it to this. So let's go down here. The black. What's the probability that I choose a black out of that first one? A black marble. Okay, 4 out of 12, which is 1/3. Then the probability that I pull an orange out, that would be 4 out of 11, right? Then the probability that I pull a black out, okay, good, 3 out of 10, because we'd already pulled the black out on this first one. And then the probability that I pull an orange out, 3 out of 9, which is 1/3, right? All right. So now that we've set all of that up, it's just a matter of doing the math. So I have 1/3. Okay, great, thank you. So I've got 1/3 times 4/11ths times 4/10ths. Can I simplify 4/10ths? Okay, 2/5 times 3/9. What does that simplify to? 1/3. Okay, so I've got all of those plus all of these. So I've got the 1/3 times 4/11ths times 3/10ths times 3/9 again simplifies to 1/3. All right. Now for the fun part. Let's multiply these out. 1 times 4 is 4 times 2 times 1. Okay, so it's 8 over, what's 3 times 11? 33 times 5. Who's got their calculator? 165. Okay, 165 times 3. 495. Okay. Then, to that, we're going to add, what's 1 times 4? Okay, so 1 times 4 is 4, times 3 is 12, times 1 is still just 12. And 3 times 11 is 33, times 10 is 330, times 3 990. All right. Well, just looking at these two numbers here, I know right off the top of my head that I can simplify that, because that's an even number and that's an even number. So I'm just going to divide both of them by 2. So I've got 8 over 495 plus, what's 12 divided by 2? 6 over, what's 990 divided by 2? Oh my goodness, okay, 495. So what's 8 plus 6? It's 14 over 495. There's our answer, and that's the, you guys, that's the hairiest one on here. That's the nastiest probability problem we had in that packet. So, so yeah, thank you for asking that question. Now that we've accomplished that one, let's go and do some of the other ones. Chantel, sorry. I didn't close it and I turned it. Okay, sorry. All right, we may need to keep the cameras on me after we're done with the class to make sure Chantel doesn't attack me, beat me up. Okay, so number 4 on a handout called the Fundamental Accounting Principle. And it says, how many different 4-digit alarm codes can be formed for a house alarm? The first digit must be a 2, a 4, or a 9. And, okay, so that's our first digit. And all of the other digits can be any number, and numbers can be repeated. Okay, so we've got a 4-digit alarm code, and again, the fundamental accounting principle is basically just telling us how many options we've got total, right? So in this first, for this first number, the first digit tells us we've got to have either a 2, a 4, or a 9. How many choices do I have? 3. Now, it says that the numbers can repeat, right? So the numbers can repeat. This next number, this next digit, can be any number from 0 to 9. So how many numbers is that? 10, right? And again, they can repeat. So I'm going to have the same choice of numbers there and the same choice of numbers there, right? So 3 times 10 is 30. Times 10 is 300. Times 10 is 3,000. So how many possible options do we have there? 3,000 different sets of numbers that can be used. All right? Okay, so let's go to the next one. And God, this would be a lot easier to find these if somebody didn't mess this book up. Man. Sorry. She takes great pride in being disorganized. I just messed it up. All right, so our next one. All right, so we are, God, Okay, here's a good one because this one actually has the wrong answer attached in the answer sheet. So this is asking you to find the probability. It says you roll a cube which has the numbers 2, 4, 6, 8, 11, and on the worksheet it has the number 2 again, but in reality the answer that they're giving at the back, the answer that they're giving in the answer sheet is if that was a 12. And so I'm just going to assume they made a typo there. Let's write that down. So we're going to assume they made the typo there because they've got a 2, a 4, a 6, an 8, an 11, and a 12. They're going up numerically. The answer that's provided is provided as if that was a 12. So again, we'll look at that. So it says you roll a cube which has those numbers. You then spin a spinner which has 4 sections. The letters on the spinner are G, F, B, and H. So we've got the numbers 2, 4, 6, 8, 11, and 12. And the letters G, F, B, and H. So what is the probability that I get a G and a 2? So what's the probability that I get a G? Okay, so we've got 1 correct and 4 possibilities. And then the 2, how many corrects do we have there? Oh, there we go. Okay, so we've got 1 possible correct and 6 options, right? So 1 times 1 is 1, and 4 times 6 is 24. So our answer is, the probability is 1 out of 24. Now, for those of you who worked it this way, as if that is a 2 and not a 12, it's only going to change just a little bit. So we've got a G, F, B, and H. Again, it's 1/4 to get the G. But then to get the 2, you've got 2 options to get the 2. So it's 2 out of 6. So 1 times 2 is 2. 4 times 6 is 24. To simplify that down, that gives you a 1/12. So if you work the problem with the 2 there, that would be the answer you get. Without the typo, that's the answer, the 1/24. All right. Our next question was on probability, and we actually had 2 on this worksheet, number 1 and number 16. So let's look at number 1 first. And the question is, how many ways can a president and vice president be selected in a class of 25 students? So we've really only got 2 positions to fill, right? President and vice president. How many options do we have? If we've got 25 students, how many options do we have for president? We've got 25, right? We can choose 1 out of any of those 25 kids. So we've got 25 options for that. Now the next part, though, for vice president, how many students do we have left? How many options do we have left to fill that vice presidency spot? We've got 24, right? So 25 times 24, anybody have that? $600. Okay, so we've got 600 total possibilities. Now number 16 is very, very similar. How many ways can a president and vice president be selected in a class of 19 students? So again, we've got 2 positions, 19 students. So 19 for president, and then we've got 18 choices for vice president. And that gives us a total of, what's 19 times 18? 242? Oh, 342. 342. Nope, that's fine. Okay. And that's, I think there's maybe one more worksheet with questions for probability. Let's check. Yeah. Oh, wait, no. Yeah, there's one more with probability, and then we're going to talk a little geometry. Okay, so number 7 says there are, oh, we already did this one. Cool. Yep, so we are done with that. So then our last one that I'm going to work on right now is a little bit of geometry problem. And it says, Robert has a great idea. This is number 19. It says, Robert has a great idea. He wants to fill a box with hot liquid chocolate and let it cool until it solidifies. The box is shaped like the figure, like the figure, and has a bottom area of 18 inches squared. So the area of the base is 18 inches squared. So if he has 66.6 inches cubed of chocolate, we all love chocolate, so put a big smile on your face. And he wants the box to be as tall as possible. How big should he make the box? So, really, this is a volume question, right? It's asking you about cubic inches, and we're going to have to set up an equation for this. Now, they've done the hard work for us because they have figured out what the area of the base of that box is. All we've got to do is figure out the height of the box to help us determine the volume, because volume of this figure is going to be the area of the base times the height of the figure. So that equals the volume. Well, we already know what the area of the base is. We were told in the problem the area of the base is 18 inches squared times the height is equal to, and we know that the volume, he's got 66.6 inches cubed of chocolate. And I'm seeing some looks out there that this is an evil number. Chantel assured me that it's not. So 66.6 is going to be the volume that we're looking for. So what is the variable that we're dealing with here? The height. So how do I, and that's inches cubed, right? How do I figure out what the height is when I've got it multiplied by 18 inches squared, the area of the base? What do I need to do? Okay, divide both sides by the 18 inches squared. And you guys, I'm doing the inches squared so I can just show you that when you're working with these dimensions, it truly does work out. So 18 inches squared divided by 18 inches squared is 1, right? What's 66.6 divided by 18? 7.
3.7.
Oh, what is it?
3.7.
3.7? Okay. Oof. Almost messed me up there. I got to open my ears. What's inches cubed divided by inches squared? Just inches, right? Okay. So the height is 3.7 inches. All right. All right, you're on, Chantel, and I will put this back in order. Sorry.
Can you see?
Yep, I will see.
Okay, I believe this actually, by the way, I have to say to Hal, thanks for messing up my binder. The only thing I had organized. The only thing. Okay.
It's back in order. It's all fixed. All fixed.
Okay. There were some questions on transformations, and we really didn't talk a lot about transformations, and so that would be something that would be good to go over today. And there are three different kinds of transformations that we can have. There are translations, where you just slide things. This one is going to be a translation where we're just sliding it. There are reflections, where basically you fold it and you reflect it over some axis, and then there are rotations. So we're going to kind of look at all three of those quickly. Translations are probably the easiest. So if we look at here, and I'm just going to go ahead and graph it on this page. We can see right here, this is hard to read, our ordered pair is at 1, -5. So starting right here at 1, -5, I need to go left 2 units and up 7 units. Now if I were going to write this mathematically, it would look like this. And that would tell me the exact same thing. This would tell me I'm going left 2 units and I'm going up 7. The 2 is in place of the x, so it's the right and left. The 7 is in place of the y, which is the up and down. So I'm going to go 2 units to the left, and then turn the corner, and I'm going to go up 7. And that's my new ordered pair. Now you can probably figure out there's actually a mathematical way in which you can add these and quickly find your new ordered pair, but you can also see that simply by tracing and counting you get the same answer. So if I go 2 left and then up 7, and then 2 left and up, and then we just connect our lines. And we have translated our shape. Okay. Then we've got reflections. On the reflection, you just have to pay attention to what you're reflecting over. Sometimes you'll reflect over the x-axis, which means this is the x-axis, so you're going to flip it down here. Sometimes you'll reflect over the y-axis, like we're doing here, so we're going to go ahead and go over the y-axis. And sometimes you may actually reflect it over a different line, and that's highly possible too. But let's go ahead and reflect over the y-axis like it's asking us to do. Probably one of the easiest, and there's a way you can look at the ordered pairs, and basically you just change the sign of the x ordered pair is kind of the shortcut. But if you want to visually see what's really happening here, you just count. I am 2 units away from the y-axis here, so if I were to look in the mirror, I would still be 2 units away, just on the other side. Same thing up here, I'm 9 units away, so if I were to look through the mirror, I should be 9 units away. And here I am 6 units away, so I should be 6 units away. And then you connect your very straight lines. And there is our reflected picture. Okay. Rotations are a little bit harder to kind of visually grasp, I think. And one thing that we have to look at first is we have to think about what it is to rotate. So if I were to draw the X and Y axis here, I know that the distance from here to here, actually what kind of angle is that? 90-degree angle. So I know that to go from here to here is actually 90 degrees. And if I did it again, I'd get another 90 degrees, and 90 plus 90 is 180 degrees. So what I'm asking here is for 270. Well, I also know that if I go an additional 90, that's going to give me 270 degrees. So basically what I'm going to do is I'm going to turn my paper 90 degrees 3 times. So if I start here, and by the way, when we're rotating, it tells us what we're going to rotate around. We're going to rotate around the origin here. So I'm going to put my pen right here at the origin, and I'm going to make the y-axis now become my x-axis. So I'm just going to rotate it. That's 90-degree rotation. So again, my hand's right in the middle. So to go right here, to do a 90-degree rotation, I turn it. You can't turn a computer, but you can put your scratch paper up there and turn your scratch paper, right? Trace it. That's what I would recommend. But anyways, then we do it again. There's another 90 degrees, so we've now rotated 180. And if we go one more time, we've rotated 270 degrees. Now, if I ignore the numbers that are written here, I know that I've got my first ordered pair is at -1, 2. I'm going to write that down. My second ordered pair is going to be at -4, 5. And my last ordered pair is going to be at -2, 9. So if I go back and put my paper the normal way it was, this is what it started like. And when I rotated it, I ended up with -1, 2, -4, 5, and -2, 9. Okay, I'm not supposed to tell anybody. Hal just used a second email address. Okay, so that's rotations. So then if you look at this sheet right here, you can see that you're being asked to do 180-degree rotation. And if you were to do a 180-degree rotation, you can see that what's going to happen is instead of being, by the way, if we were to number these quadrants, we number them going clockwise. Sorry, we number them going counterclockwise. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So if we were going to rotate this, we can see that our shape, which is currently in quadrant 2, if we were to rotate it 180 degrees, so we turn it once, then we turn it twice, we can see that the position is now down here in the bottom. Down here in the bottom would put it in quadrant 4. Okay? And same thing with these other ones. So you should be able to do those ones hopefully now. We have lots of other problems to go through, so let's go ahead and go to one of our next ones. From packet 1, I believe, we had some questions on graphing. Let's see. So let's go ahead and look at the first question. that was asked, and that was question number 22. And what we're told here is a line passes through the point 1, -7. The line is perpendicular to another line whose slope is 1. You can't read that, can you? I still think you still can read that. Okay, so let's go ahead and start from the beginning. We're looking at a line that passes through the ordered pair 1 at -7. And we want it perpendicular to another line whose slope is 1. Now we've talked about this before. What can we say about perpendicular lines? We know that perpendicular lines look like this. They cross at a 90-degree angle. And what can we say about the slope? It is the negative reciprocal. Okay, now be sure you get both the negative and the reciprocal there. So if the slope here is 1, then the reciprocal of that, so if this is slope 1, my perpendicular slope is going to be -1/1, because I took the reciprocal of it. But 1/1 is the same thing as 1, and that's why it looks like we just took the opposite. So our slope of our line is -1. So I'm looking for something that goes through the ordered pair 1, -7, and is -1. Now, if all I had to do was graph, I have enough information here to actually graph it. If I don't need to write the equation of the line, I actually have enough information to graph. All you need to do is a point and a slope in order to graph. So on my graph, I have the ordered pair 1, -7. And then from here, I'm going to move my slope, which is -1. Well, what -1 means is I have -1/1, so I'm going to go down 1 into the right 1. Or I can do the opposite. I can go up 1 into the left 1. But I'm just going to go ahead and repeat. It's like rinse and repeat, rinse and repeat. So there's my actual line. Now, if I do that, I actually see very quickly that my intercept is right there. So the equation for my line, and my intercept is at -6, so the equation for my line is y equals -1x minus 6. Now, -1x is the same thing as saying -x minus 6, which is probably how I would find it. Y equals -x minus 6. Now, if I go back to the problem here, I can actually find the same solution, but I can find it algebraically without having to graph. And I go back to my standard, y equals, sorry, I said standard, but it's the standard is in the one we go back to the most, and it's the slope-intercept form. It's not the standard form, if you recall. So I've got y equals mx plus b. I know that my m is -1. I have an ordered pair here. This is my x value. This is my y value. And I can substitute those in. So y is -7, x is 1, and now I just need to figure out what b is. So I end up with a -7 equals -1 plus b, or -6 is b. Writing it all back together, I have y equals a -1x minus 6, or plus a -6. So that goes back to finding the slope if the line is perpendicular. What would we have done if it asked for not the perpendicular slope, but the parallel slope? So if we'd asked for the parallel slope, we would know that the slopes are the same. Okay? And that's one that you just might want to remember, kind of jot down, that if we want parallel slopes, we want the same slope. If we want perpendicular, So if the slope of 1 is parallel to the slope of 2, then they're going to equal each other. If, however, we want them perpendicular, then we want, when we multiply them together, the answer to be -1. Or the negative reciprocal. Okay. All right, let's go to some of the other questions. Don't tell Hal I just did the same thing. I'll keep it. I'll close the binder, then I'll turn the page. All right, you know, simple things in life. Okay, so then we're asked, was question number 36 on the very next page. We were given the information that the y-intercept is -32, and, sorry, I like to write very crooked, the x-intercept is -8. And you were asked to find an equation of the line. Okay, well, in order to do this, we have to understand what the y-intercept really is. If we were to look at it in a graph, it's where it's going across the y-axis, which means it's an ordered pair. It's actually, and if you can see I'm not going to be able to graph -32 here, but if I think about it, if it's on the y-axis here, what is my x value? 0. So it's actually the ordered pair 0, -32. So now if we think of the x-intercept then, what would my y value be? 0. So here I have the x-intercept at -8 and 0. But what's nice is I now have 2 ordered pairs. And we can find the slope when we're given 2 ordered pairs. How do we find the slope when given 2 ordered pairs? Right, we subtract them. Now remember, you want your y's over your run, or your y values over your x values. So I'm going to take a -32 minus 0, and that's going to be, and this is where, when Hal said to be consistent, it doesn't matter what you start with, you just have to make sure you start with the same one again. This is why sometimes it's really helpful to label things. If I've got this being my first one, so that's x1, y1, and this being my second one, actually I have that, that's fine. So I've got -32 minus 0. I want to make sure I start with this one again. So I'm going to have 0 minus a -8. Now we just go ahead and figure it out. We've got -32 minus 0 is -32, and 0 minus a -8 is the same thing as saying 0 plus 8. So I end up with -32 over 8, which is -4. That's my slope. Now it's nice because of the ordered pair they gave us, they actually gave us the y-intercept. I don't need to go any further. I can go ahead and simply write this, and I get y equals the slope times x plus the intercept. That's my answer. Now I could see why this would be a question, and thank you for the one who sent us this question. The answer was written like this. So then the question becomes, is this an incorrect answer? Sorry, there's a little bit of shine there. There we go. Yeah, hopefully you recognize that what's different between these two equations is here we have it solved for y. Here, for some reason, they wrote it as solved for 3y. If we were to go ahead and divide all of these by 3, we would end up with the exact same answer they already had. And that comes down to equivalent forms of the answer. And that would be something that would be appropriate if they have choose all that apply. you may need to look for the equivalent forms of certain expressions or equations. Or if you've done the problem and you can't find the answer, go back and look to see if there's an equivalent form to what you've done. Okay. Then we've got, and I think some of these, because they started getting really strange slopes. For an equation of the line that passes through the point 0, negative 22, and is parallel to the following equation. So we've kind of talked a lot about this one already. This, by the way, is number 41. And we want to write the equation of line that passes through the point 0, negative 22, and is parallel to y equals negative 16/5 x minus 22. He gave us a very nice, not nice looking equation here. And in the answer key, it looks like they made it crazier. Okay, so we want a line that is parallel. So what do I know about the slopes? We kind of already just talked about this. The slopes are the same. So basically, I want that slope. Okay, so our slope is negative 16/5. Look at our ordered pair again. What can we say about our ordered pair? It's the y-intercept. So if we were to write this in equation, we've got y equals our slope, and then our y-intercept, right? It is the exact same line. And the reason is because our original line passed through the ordered pair 0 to negative 22. There's no other parallel line, and if you think about that, and I'm going to change the number to 0, negative 2 to kind of, because I don't have negative 22. If I've got an ordered pair here, and I already have a line that's going through it, is there any way I can be parallel to this line and pass through that exact same point? The only way I can is if I'm the exact same line, because all the other lines are going to be crossing at different intercepts. Okay? So I would almost say that was a trick question. That felt like a trick question, didn't it? Okay. Let's move on to some inequalities, graphing inequalities. The question came up about problem number 36 on the graphing inequalities. Now when you graph inequalities, here we have 4 inequalities that we graph, and they're going to form a shape, and we needed to basically say what the vertices are, where they crossed. So we're going to go ahead and do this one, number 36. And our equations that we're dealing with are 2x minus y is greater than or equal to 12. 5x minus 3y greater than or equal to 28. X plus 3y greater than or equal to a negative 8. And 2x plus y. I wrote that down wrong, I apologize. We have a greater than, yep, it's greater than. And this one's a less than, or equal to 9. So these are our equations. Now what you'll notice is these are very hard to graph right now because they're not solved for y. So the best thing that we can do right now is to actually go through and solve each one of these for y. So I'm going to put this one aside with my equations, and we're going to solve each one of these for y. And then we'll graph them. Okay, so the first one, we have 2x minus y is greater than or equal to 12. So to solve this one for y, I'm going to minus 2x from both sides, and I get a negative y is greater than or equal to a negative 2x plus 12. Now this is an actual great one to look at, because I have a negative y right here. I can't have a negative y, so what do I need to do? Either multiply or divide by a -1. It doesn't matter here which one I choose to do. However, when I do it, this inequality is going to change directions. And that's one thing that we want to remember. Anytime you multiply or divide by a negative, your inequality changes directions. So I get positive y, so I'm going to change all the sides to opposite. I get 2x and a -12. Okay, let's go solve the next one. We have 5x minus 3y is greater than or equal to a 28. So this time I'm going to minus 5x from both sides. And I get a negative 3y is greater than or equal to a negative 5x plus 28. Just like before, I need to get the y alone. So this time I'm going to divide by -3. But because I divided by a negative, that inequality has to flip directions. So I get y is less than or equal to, now I can't figure that out nicely, so I'm just going to go ahead and leave it as 5/3. And I have 28/3, which doesn't go nicely, so I'm just going to leave it as minus 28/3. Here's my second equation. Okay, let's do the next one. We have x plus 3y is greater than or equal to a -8. So this time I'm going to minus the x from both sides. Seems to be pretty standard there. We've got 3y is greater than or equal to a negative x minus 8. I'm going to divide everything by 3. Do I need to flip my inequality direction? No. This time I did not divide or multiply by a negative number, so it just stays as it is. And I get y is greater than or equal. Now this right here can be written, x divided by 3 can be written as 1/3 x. Because I've got a 1 in front of that x, so I can just pull that whole fraction out. So this is a negative 1/3 x minus 8/3. All right, one more. We have 2x plus y is less than or equal to 9. This one I need to minus 2x from both sides. And I get y, and I get a negative 2x plus 9 over here. Do I need to split my inequality direction? No, I don't, because I did not multiply or divide, so it stays a less than or equal to. Okay, so what I have now are these four inequalities that are solved for y. So we're going to go ahead and we're going to graph them now. And we're going to use our graphing tool in which to do that. By the way, I do stand corrected. I was told also by somebody else who's recently taken the test that you can take your calculator into the testing center there, and they'll just clear everything that's in your memory. I would still recommend double checking. I was also corrected that they'll provide pencils for you. So don't panic about that. Okay, so let's go ahead and go to graphing. Flip here. Oh, okay, how did it know I was already on the computer? It's just brilliant. Okay, so right here on my calculator, I have a graphing. We're going to go ahead and go into the graphing, and I want to make a new graph. Now, it's not going to do the inequalities for me, but that's okay, because I can figure out what's being shaded as I look at it. What I want to see is where the graphs, especially being this where I'm looking for intersection points, and these are like negative 28/3 is the intercept. So we're going to use the graphing technology here to do it. So the first equation, and we just type it directly in, I have 2x minus 12, and we can make it a really dark line so we can see it. And, okay, we'll make that one red. Let's add a new graph. This time we are going to add a a new graph that is, we'll make this one green. And this one will be 5/3, so I'm going to put in parentheses, 5 divided by 3, because that's really all 5/3 is it's just 5 divided by 3. X minus, and again I'm going to put my fraction in parentheses just to make sure it understands that it's a fraction. I don't want to leave anything up to chance. So I have 5/3 x minus 28/3. That one's green. Click OK. Let's go ahead and add a new one. This one is going to be negative, and then 1/3 x minus 8/3. Make that one blue. And we'll add one more graph here. The very last graph we're going to add is negative 2x plus 9. And I guess we could have made some of these dotted. What color should we do this one? We've got more colors down here. I'll do that color. All right. And then we can go ahead. If we want to change the window, right here we can see it's actually going from a negative 6.5 to 6.5. I'm actually going to take it out to just to a negative 10. Y minimum, negative 10 to 10. I want it to count by 2s. I want to be able to see the axes. So I'm going to go ahead and click OK now. And we're going to go ahead and graph. And we can now here's where we have to superimpose now the inequalities. So we have to go back. I should have written the colors. Hold on, let's go. What color did we do first? Was the red one, right? So the red one we wanted less than. So if we look at the red is less than, it's going to be this side. Was our red one the first one? Okay. Yep. Red one's less than. I can see where there was a question here. I'm going to have to actually. Okay, so the first one, this was red. This one's green. Now, if we were doing on this, if you're doing this on paper, it'd be a lot easier. You could see to shade as we were going. And then what you're looking for is you're looking for where all 4 graphs lap on top of each other, so the darkest area. Depending on what graphing calculators you have, some graphing calculators actually allow you to do inequalities, and they'll shade it for you. So we'll go ahead and just figure this out here as we go back to graph. Okay, so our first one is a less than, and less than is going to be below this red line, so we're not talking about anything above the red line, we're talking about everything that's below this red line so far. So down here. Then the green is a less than, so now we're talking about this region that is constrained by this red line, and then turns, and this green line is that region we're talking about now. And now we're talking the blue is a greater than, so now we're constrained by green till we hit here, red till we hit here, and then the blue, because we want above the blue. So we're right here. And then the purple is a less than, and so we're talking about this region. And I can see then where the question comes in, because there's actually only 3 ordered pairs here. There's this ordered pair, which is right at, x is right around 5.5, and y is right around negative 5.5 is our first ordered pair. The second ordered pair is going to happen right here, where x is right around 4 and y is right around negative 4. And our last ordered pair is going to be right here, where x is right around 7 and y is right around negative 5. So that there is, that was a great review to go through the different inequalities, but the answer that was reported there, I believe they have the, they have a different answer constraint there. So that's one thing you just got to really watch for those inequalities and make sure that you're shading on the correct part. Again, you notice the shortcut that I was doing here is if it was greater than, it's above the line. If it's less than, it's below the line. And that works for everything except for your straight up and down lines. Then you would need to do your right and left. So if it's a greater than, it's above the line. If it's less than, it's below the line. Okay. And I think, and how you got all the probabilities?
So if it didn't have an equal part to it, maybe dotted or something.
Excellent question. The question was if it didn't have an equal part to it, would it be dotted? And the answer is yes. The equal part is what actually makes it be a solid line there. So without that less than or equal to, we would have a dotted line. If it was just a less than, we would definitely have a dotted line. Excellent question. Okay. Just trying to make sure everyone who's emailed questions that we've got all of your questions covered. I think that was it. There is one more that I do want to kind of talk about a little bit, and that is when dealing with the algebra, we need to look at the graphs and interpret the characteristics of the graphs. Was that already on? So it just knows? Okay. And what I want to introduce you to is some notation here that may panic you a little bit, but it doesn't need to. And so if I introduce it to you, I don't think that you'll panic necessarily by this notation. Now we're just talking about the graph behavior here. Now you could be asked different questions about the graph. You could be asked about the local maximum or the local minimum. What it's asking you then is, where's your high point and where's your low point? Maximum would be your high point, your minimum would be your low point. Okay, you could be asked characteristics about the particular graph. For instance, the end behavior of the graph. Now what I mean by the end behavior is if we look at this graph right here, we can see that this graph is going down on the end. So we would understand if this graph continued, it would probably continue straight down. Same thing on this side, we would expect it would continue straight down. Whereas if we look at these graphs, we can see that it has different end behavior. Here they're both going up, and here one is going down and one is going up. So let's go back to that notation. The way that this notation is read is what we're asking here is what happens when your graph, because remember f of x is your function, so we're asking about the function. So what happens when your graph, and I can rewrite this so we can see it better. Sorry, we're like 8. Take me one time. You can see if you weren't familiar with this notation at all, this might panic you a little bit if you were taking a test. So we just want to kind of talk about it so you know what it is. So what this is saying here is f of x is our graph. Okay, that's our function, our graph. It's our y values, if you will. Okay, and this is our x values that we're substituting in. So what this is saying here is what happens, and the limit is where you're looking at it at its extremes. You're looking at it continuously and seeing what's happening here. So what we're looking at here is what happens when x approaches negative infinity. So if we think of the x-axis here, what's happening to our graph as x continues to go to the far left? So our end behavior is what we're asking about. When x approaches negative infinity, what happens to our graph? Here we're looking for the graph where the end behavior also approaches negative infinity. So the y values approach negative infinity. So what would that look like, do you think? Would that be a graph that's going up or a graph that's going down? Probably down. We're looking for y values. So if our y values right here are approaching negative infinity, we're progressing down even further. We're going down to negative infinity. Okay, so let's take that back to our graph. Which one then of our graphs satisfy that constraint? Does this one, as x approaches negative infinity, is our y values approaching negative infinity? So this one matches that end behavior. Let's see about this one. Does this graph match that end behavior? How would we write this one? We would say the limit of f of x as x approaches negative infinity, because we're still talking about those negative x's here, as x becomes more and more negative, what happens to our graph? It goes up. So it's going to approach positive infinity. So basically, it's just a fancy way to talk about the end behavior. Instead of saying it's going up or it's going down at the ends, this is more mathematically how to talk about that end behavior of the graph. So let's actually ask, this is a benchmark question for one of our math classes. So let's actually answer this particular question. And it is, we're looking for, as x approaches negative infinity, f of x approaches negative infinity, and where x approaches positive infinity, f of x will approach positive infinity. So we've already talked about this one. What does this one mean? I'm going to rewrite it so we can see it. So this time, instead of going negative infinity, it's positive. This just means as the x becomes more and more positive, our graph is going to go up. So the one that would match would be as x becomes more negative, our graph goes down. And as x becomes more positive, our graph goes up. Okay? Just wanted to make you, that's, when we talk about end behavior of graph, you know the end behavior of graphs, sometimes it's just the notation that can throw us off. And so that was one of those questions I didn't want the notation to throw us off. Okay. How? Did you have any other problems you wanted to work?
No, I didn't. Do you guys have any problems that you want us to work? Fantastic. Okay.
Geometry on perimeter and area. I don't know what this is made.
Can I steal your... And by the way, sorry about this to those in Adobe land. We've got donuts and water over here for everybody who's here. If you guys want to go ahead and grab one. And then we will look at number 8 here.
And as you're grabbing one, someone left this here last week. Does this belong to anybody that's here? It's a black binder. Okay, so we have it here. If it's yours. In Adobe land, if you left your black binder, it's here. So.
Okay. So, number 8 says that we've got a rectangle. And we know that the area is equal to 988 centimeters squared, or excuse me, meters squared. All right. It says the height is 11 more than 5 times the base. So let's say this is my height and this is my base. Let's call our base x. So I know that my height is 11 more than 5 times the base. So I've got my base is x, so 5 times x, and then 11 more than that, plus 11. So now I need to figure out what x is, and I can figure out all of this other fun stuff, right? All right. I know that my area is going to be my base times my height, and that's going to equal the area. So we've got the base, which is x. Okay, x times the height, which is 5x plus 11. And that's equal to the area, which is 988 meters squared. So I know we're dealing in meters here, right? So we call this 8 meters, and that's meters as well. All right. So distribute the x. So I've got 5x squared plus 11x equals 988. I'm going to subtract 988 from both sides. So I've got 5x squared plus 11x minus 988 is equal to 0. And now we've got a choice. We can use the quadratic formula. What was that? Oh, lovely. Or, yeah, we can, that's a great choice. Or we can factor, or we can use the solver on the calculator. Thank you, Chantel. That's awesome. I was going to do it the wrong way. So we'll come to the calculator. Okay, so my equation, I've got 5x squared plus 11x minus 988 is equal to 0. And so my value of x is 13. So that's going to be one of my values. Now I'm going to get two values here. But by looking at this, I know that when I factor this out, because this number is a negative, I'm going to have something x plus...
Switch it over, we can down that.
Oh,
Just hit the
switch it
button
over.
first.
Sorry. Okay. So I know that by factoring this out, I'm going to have something x plus 11, or plus, not plus 11, plus something, and I'm going to have something x minus something, because these two numbers multiplied together have to equal that negative 988. So I know that when I set each piece equal to 0, I'm going to end up with one of them being a negative number and one of them being a positive number when I solve it. So I know that x is either going to be like a negative 7, whatever, or a positive 13 is one of my answers that I'm going to get. Because we found that out from the solver. So with the solver, that's going to tell me that it's going to make it easier for me because I know, like I said, one of these answers is going to be a negative. And when we're talking about measurement, can I have a side of the rectangle be a negative number? No. So we find out here that x is then equal to 13. So x equals 13 meters. Well, what does that mean that h is going to equal? Okay, good. So I'm going to plug my x in here. So I've got 5 times 13 plus 11. What's 5 times 13? 65 plus 11? 76. So 76 meters. All right. Have we answered the question? Well, let's go back and read it. And remember, this was one of the cues that Chantel was talking about at the beginning of class today. When you're working on the Praxis, double check to make sure you're getting the answer that they're looking for. So let's read back through here. It says the area of the rectangle is 988 meters squared. The height is 11 more than 5 times the base. What is the perimeter? Okay, so we haven't answered the question yet, right? It's asking us what the perimeter is. So if I know that this side is 76, and this side is 76, this side is 13, then this side is 13. Because it's a rectangle, right? And the opposite sides are congruent. So my perimeter is just the distance around. So I can take 13 times 2, or 13 plus 13, however you want to work that out. We'll just do 2 times the 13 plus the other side is 76, and we'll take 2 times that as well. And that's going to equal the perimeter. And again, we're dealing in meters. 2 times 13 gives me 26. 2 times 76 gives me 152. So 26 plus 152 is going to give me 178 meters is equal to the perimeter. All right, fantastic. Any other questions? We're going to put Chantel on the spot for this one.
Unless it's a probability.
Did we announce that there's trees over here?
What was that? Yes, I did. Yep.
Well, go get them. That's what they're there for. Not that I don't want him to listen to you.
Okay, we're going to take a 30-second break for you to stand up, stretch, and go get treats.
There we go. Thank you.
Yes.
You're smiling.
It's easy. So it's
So this is this one. So it's this one. This one here. It's too much. No, it's neither. It's just
This one's.
Yep.
And then she wants to know these ones.
I think just
it's going to be yours.
Yeah, I think maybe just the first. All right, while Chantel is getting ready up here to answer a question, are there any other questions? And I'll come grab that information from you guys and I'll get ready to answer that question. Anybody? So what's the
Okay, so hopefully you're enjoying your snacks. Here's another topic that we really didn't touch on, and we probably should, and that is sequences. So we're basically, I'll just go ahead and show the picture here. We're being asked if this is arithmetic, geometric, or neither sequence. Well, really the big difference between the two is an arithmetic sequence is when you're adding or subtracting the same number over and over again. So to move from one number to the next one, you've added something or you've subtracted, and then you continue that adding and subtracting of the same number over and over again. Geometric, the pattern is that you constantly are multiplying or dividing by the same number. So you see the big difference is arithmetic is where you're adding and subtracting. Geometric is where you're multiplying or dividing. Okay? And then neither would be if it doesn't fit into either qualification. So if we look at the first one, we have 1, 3, 6, 10, and 15. What do you think? Arithmetic, geometric, or neither? Right, so it's moving up right here by 2, then it's going up by 3, then it's going up by 4, and then it's going up by 5. However, we're not adding the same amount each time. Therefore, this does not count as an arithmetic one. In order for it to be arithmetic, it would have to be something like 1, 3, 5, 7, 9. Because here it would be going up by the same amount each time. And it's not geometric because in order for it to be geometric, it would need to be something like 1, 3, 9, 27. Where geometric then, we're timesing by 3, timesing by 3, timesing by 3. Okay? So let's go ahead and look at number 2. Number 2 is 40, 43, 46, 49, 52. What do you think? Yes? It's arithmetic. Okay, let's go ahead and look at number 4. This one's a little more challenging. Negative 4, 12, negative 36, 108, negative 324. What do we think? Well, first, are we adding the same amount each time? No, we're not. So we know it's not an arithmetic sequence. It's geometric. It is geometric because we are multiplying by negative 3 each time. Okay? All right. Then we had some notation, some funny notation, if you will. And there are things that look like a sub n equals negative 43 plus 4n. What this is a formula for us to be able to find any number in the series that we wanted to find. N is going to be your number in the series, so if I actually wanted to write down what this series was, I would start with 1. If my n is 1, I would figure out what that answer is. So if I put 1 in place of n here, I would get negative 39 would be my first number. Then to find my second number, I would put 2 in place of n, and that would give me my next number, which would be negative 35. So you could actually write this out if you wanted to, but we don't need to because right from here we can actually tell what kind of sequence this is going to be. We can, do you see here how each time we're just going to be adding 4 more depending on what number it is? So the first one we add 4, then on the second one we're going to add 4 again because we have the first 4 plus 4 more. The third one you have the first 2 4s plus another 4. So if we wanted to write it like this, we could say our first number is this one. Our second number is the previous one plus 4 more. The next one is the previous plus 4 more. So with that being said that it's plus 4 more each time, what kind of sequence do you think this is? It's a arithmetic sequence. So what would a geometric sequence look like? Well, it would possibly look something like this. So again, where n represents the number that we're at, so on the first one, we would put 1 in place of n, which would give us negative 3 to the 0, which is 1. And we have 1 times negative 4, so we're going to start with negative 4. Our next number, we would put n is 2, so we have 2 minus 1, which means we're going to have negative 3 to the first power, which is just negative 3. So we're going to have negative 4 times negative 3. And then if we continued the pattern, we'd have, do you see how each time we're going to be multiplying by 3, negative 3? Our next one, if we were to figure it out, should be negative 36. So hopefully you can see, because this is a multiply, each time we're multiplying. So if I take my first number, it's just negative 4. Then my second number is going to be negative 4 times negative 3. The next number is going to be negative 4 times negative 3 times another negative 3. We're just going to be adding those negative 3's each time. So this is a geometric sequence, because we're changing it by multiplying each time. So that was just a little bit funny on the notation. You go a little bit further into the notation, and you see something like, I always thought A's and 9's don't really belong in the same sentence, right? They look the same. Okay, so A sub n equals A sub n minus 1 plus 2, and A sub 1 is 9. What this means is, in our sequence, the first number is going to be 9. Then what this means up here is we take that first number and we add 2 to it. Then to find our next number, we take our previous one. That's why it's n minus 1, as you're always using the previous. You're taking the previous one and adding 2 to it. So now we're going to get 13. And then we're going to continue the pattern. We take the previous one and add 2. Previous one and add 2. So what kind of sequence would this one be? Arithmetic sequence. And the geometric one, okay, so this one again, this one tells us our answer is when you take the previous one and times it by negative 5. And we're going to start with 4. So we're going to start with 4. Then we're going to take that previous one and multiply by negative 5. Then we're going to take that previous one and multiply it by negative 5. So what kind of sequence do you think this one is? Geometric. So that's identifying whether it's arithmetic, geometric, or neither, in a nutshell. Other questions? In Adobe land, do we have any questions?
No questions. Okay. All right. Well, let's end class then on that positive note. But what I want to do is just remind you guys that even though our classes are over, if you have questions, please feel free to email either Chantel or myself. We'll get back to you as soon as we can. And we just want to make sure that we're giving you guys as much help as we can to prepare you so you can be successful on the Praxis. So yeah, please let us know if we can answer any questions for you. Again, all of the information, all of the classes, all of the handouts, all of everything is located on the website updc.org. So you know what? Here, let's just switch back over to this, and we'll go here. Okay, so you can go to updc.org. If you can't remember the the /Praxis part, it's real quick and easy to get to. You just click on what's happening in the UPDC, and then you go down to the Winter-Spring 2014 PD workshops. And right at the very top of them is, because we are the best, is the Praxis 5169 prep class. Click on that website and scroll down, and there is all of the information. If you'll notice that Chantel's email is there as well as mine, so feel free to email us with questions. All of the handouts and the videos of the classes are still up there. Make use of whatever you can, and good luck to you guys. Yes? That is a good question. Becky, do you know how long this information is going to be on the UPDC website?
At least until the end of June.
Okay, so at least until the end of June.
So I need to read what you show us is on here, right? The beginning of the first one.
Yeah, all of them are on here. So yeah, week 1.
The one you show us at the very beginning, week 1.
Yes. Yep, it's on here. Yep.
So
all of
the question was, was in Adobe land.
Yes.
The one that we showed at the beginning is on here. Week 1 is on here at the very beginning, at the top, and also that study guide. It's me. That study guide that we did is right here. That link to that study guide.
Yep.
Yes, the one you show us at the beginning. Show us what to do.
Yeah. The video that we showed, is that the one you're?
No, I think we started class today.
Oh yes.
Today.
Oh, the stuff we started class today. Yes. Yep. That's that review guide right there. Yep. Absolutely.
Okay, we have a couple questions from Adobe land.
Okay.
The first one is just the last class.
Yes, this is the last class.
For number 1.
For cohort 1. There is cohort number 2, and they start March 5th.
The next Wednesday.
Okay, March 5th.
And they want to know, will it be different problems?
Different instructor brings different things.
Yep.
So
Yeah. So
click on the computer and watch that.
yes. So the answer to the question is there will be a different instructor for the next cohort, but they'll be covering the same topics. And then we have a question here: can we watch? Can we hop on and watch that cohort? Are they going to post that online just like they posted these? And the answer is yes, absolutely.
You can have another full review.
Yep.
You just can't get credit to take it again through USLE, and you have to be registered to do it. So you're welcome to get online and watch.
So those of you in Adobe Land, what was just said is you can watch as many times as you want. You can do the second cohort. You just can't get credit twice for the same course. You have to be registered in order to get the credit.
All right. Any other questions? Yes.
For the, I think it was the second session when you did probability, those three, you gave me 3 worksheets, and the one with all the probability, and did you have an answer sheet for those? Because I don't know.
That's when you printed out the answer sheet.
Oh, there was no answer sheet for that? No, we didn't have an answer sheet
There
for
were
that.
2, yeah, there were 2 pages, and they were all written out for the probability. And I was wondering if there were answers to each.
You know what, we didn't get an answer sheet for that. But if you want to email me and have me check the answers, I'm willing to do that for you. So the question was, if there's if you are working a problem and there's no answer sheet included with it, or you're not sure if the answer that is included with it is correct, because there are some in there that the answers are incorrect, email us. We will work the problems and get it back to you and let you know whether what you're getting is right, or if the answer in the answer sheet is wrong. We'll let you know.
Be sure to include Praxis in the title of the email.
Yes, yes.
That way you don't get lost.
Just one clarification. If you would like to attend the second cohort, meaning coming and working with the next instructor, you're welcome to do that. We have the right to do that. So you can do that. You just won't get credit for it, but you're welcome to come in and sit in with the next instructor if you'd like. So,
I'm thinking about different instructor, I have different questions.
Yes.
a new instructor, a different instructor is going to teach things differently, just like each year your kid moves to a different class. You know, they're going to get different instruction. So, any questions? Relicensure points should just be on Cactus,
Yeah,
right?
they should just be on Praxis. They'll be on Praxis after we look at all the roles that you attended. We're logged on Adobe.
But it's automatically for campus.
Those of you that are ATP teachers, for those of you, I will make a certificate for you. So you'll have it for your teacher. Any other questions? As far as the project not license goes, remember you will have those available to you until March 5th, which is next week. I will play with the numbers. Let me see how many we get coming this next cohort. If I have enough, I'll let you keep them until you take the test. If not, then I'll have to pull them, and then after the next cohort, I can send them out on a first come first served basis for you. Does that make sense?
Is that a resource that you just talked about?
Project Knot are online practice modules for the middle school now.
Now, I still have to learn some of the good last year's 00698. I could look at 2 of 069. Or is it the same?
It's just middle school math, or
Okay.
yeah,
So
it's
there's
just
no-
the practice modules.
Okay.
Yeah. Any other questions for me?
Thank you.
Thank you very much, you guys. Thanks for sticking with us.
Make a judgment on it.
Thank you guys and good luck.
Good luck on your test. Okay, this is the new